Okay, so this video is going to be about how to run the um, algorithm developed by Marib Akanda in 2016. And this algorithm looks at choriocapillaris images, and it highlights the flow voids and comes up with a mean sort of summation of all the flow voids. So we're going to begin first by opening image J. This is the main program in which the algorithm works. So if you'll notice, I've downloaded Fiji, which is essentially image J. And so the first thing we're going to do is we're going to get our images. So as you can see here, I'm going to go to my H drive and prepared a little tutorial folder. So here are our original images. So the first thing we're going to do is we're going to look at actually some of the images. Now you'll see I'm selecting 3 specific images, and as you can see, you can simply go to your folder and drag and drop the image by just hovering over the image J toolbar. So what you'll see here is you'll see a standard picture of a superficial capillary plexus. Note that there is a watermark down there, which we will have to remove. And if you look carefully, you can see there's a motion artifact from horizontal movement. This is superficial capillary plexus. Here's the choriocapillaris, and here's the avascular zone. So I'm going to X out of these right now, but as you can see, each one has this watermark, which is going to get in the way of the algorithm. So we're going to have to remove it. So luckily, Marib has developed an algorithm for removing the watermark. So if you'll see, I went to Plugins, Macros, then I went to Edit, and I'm going to now find the macros or algorithms. Macro here is another word for algorithm that Marib developed, and here we go. So we're doing choriocapillaris, and here's this crop watermark. You'll see it pops up right here. Now what we're going to do is we're going to go to Process, and we're going to go to Batch, and we're going to do Macro. So now what Batch Process does is that it essentially repeats a specific command across an entire folder. So we want to select our input, which in this case will be this folder, because this folder contains all of the original images, and we want all the images to be cropped. So this will be our input, and where do we want it to spit it out? Well, if you click here, the way I've set it up is I actually have a subfolder for all cropped images. So I select this as my output, and I would like to now specify to the batch process program here what I want it to do. And I can essentially copy and paste everything here into this box, and it will run anything in this box as a macro. So you'll see now I'm going to hit process, and you can see it's thinking up here a little bit, and so now we're going to go and we're going to see if it worked. So just to orient you, here's choriocapillaris tutorial. These are the original images, and now we're going to go back and we're going to go to the processed images, and we're going to look in here, And would you look at that, all of them came in here, and we can check to see if they got cropped. You'll notice in the corner now there is no watermark. So that's awesome. And so now what we're going to do is we're going to make a new folder, and we're going to label it avascular. And we're going to pretty much take all the avascular images here, and we are going to drag and drop them in there. Just double check I didn't miss anything. And so now a couple of setup things moving forward. I've put them all in the folder there. A couple of things you want to make sure are set. So for one, you want to go to Analyze, and you want to go to Set Measurements. And you want to make sure the box is area, standard deviation, min and max, limit to thresholds, and of course median and stuff. All of these are checked. You want to make sure all these are checked. And we're going to hit OK. Another thing that's important is to set the scale. And it's important to note that you can only set the scale once an image is open. And how do you know the distance in pixels? Well, this is established by sort of looking at the original image when you get it off the clinic computer. But because I've already done this, I can let you guys know it's 844 pixels. And for the choriocapillaris, we're using 6 by 6, and the 6 here refers to millimeters. So you don't want to touch the pixel aspect ratio, but you do want to say, essentially you want to tell image J that the 844 pixels is equivalent in real life to 6 by 6 millimeters. And you want to click global to make sure it applies to all images, and you're going to hit OK. So now that we've set our scale and our measurements, essentially the way that this algorithm works is that it looks at, so you'll see actually, this happened as I was talking, you'll try to drag an image and this dialog box will pop up, and usually you want to just click disable global calibration, or you want to uncheck this box and check this box so it doesn't happen again. So essentially, as I was saying earlier, this algorithm works by essentially looking at the avascular zone, and it's going to take the mean blackness, or how black the pixels are here, and it's going to come up with a value. And what it then does is that it scans through this entire image, and anything that falls into the range of sort of the blackness of the avascular zone will be quantified as black here. And when it's quantified as black here, it will highlight it and call it a flow void. So you're essentially using the avascular zone to determine what is avascular in the choriocapillaris. And any areas that are avascular in the choriocapillaris are in this case assumed to be a flow void. So that's sort of the concept behind it. So you might be asking yourself, well, how are we going to know what the values are, what the average blackness value is? Well, that's what this next step is going to do. So now we're going to X out of this, and we're going to go back to Process, Batch, and you'll remember previously we did Batch, and then we went to Macro. This time we're going to go to Batch and Measure. And in this case, we're going to, go into Cropped, and we're going to select the avascular folder. And when I do this, it will literally spit out all the measurements for the avascular folder. And so this is usually between, this is usually pretty small. It looks like we have a couple of big ones. It's always safe to double check, make sure something didn't go wrong. Okay, so you can see that 11317 OS avascular right here has a pretty high value, and it's got a lot of schmutz in here. So that's something to keep in mind. You know, if you're a fellow, you know, maybe this might be where you might want to exclude based on clinical reasoning. I usually just go along with it just to get the output value. And so usually we like to keep all these results. So what you can do actually is I like to put them in an Excel file. And so open this bad boy up, and you can just copy and paste all of these, really. So you just Control C, and we're going to go into here, and you can just paste all of these values in. Now, this is where we're going to come up with our threshold values. And so threshold here means the threshold of blackness that we're going to use to judge the choriocapillaris. So you will usually have threshold 1 and threshold 2. So, and here's our mean, and here's our standard deviation. For anyone wondering how I know that, it truly just says it right here, mean, standard deviation, and that's how I know. And so essentially, you know, we're just going to plug in a little formula here. It's going to pretty much equal this plus, so I mean the first threshold is only going to be 1 standard deviation away, and then the second threshold is going to be 2 standard deviations away. So in this case I'm going to do 2 times the standard deviation. Yeah, I'll take the correction. Okay, and so I'm just going to drag to apply this formula to all of these. Okay, and so we're just going to hold on to this. We're going to need this later. We're going to have to enter these thresholds later. But for right now, we're going to continue processing the rest of the images. So to review, we have so far, we have taken the original images and we've cropped them. Now the next step is to remove projection artifacts. Now, a quick review of vascular anatomy in the retina will say that, well, there's, you know, you have your superficial, deep, and then avascular, and then choriocapillaris, all sort of layered on top of each other. And so sometimes it, as the OCT-A is collecting its image, it might sort of project shadows of overlying vessels onto underlying layers. So all you have to do is, we're going to go into the cropped, make sure you're working from the cropped images, and I'm going to get the macro or algorithm that will remove the projection artifacts. Notice I go to macro and edit. You can also go to macro run, but I just prefer edit just to, you know, see the code. And so you're going to select this one, rem pa create cc win. So remove projection artifact is essentially how I read it. So you'll see there's a bunch of code here, and we'll put it up here. Now what you want to do is you want to select 2 images, the choriocapillaris and the superficial capillary plexus. And you'll notice the 2 that I'm selecting have the same date, it's the same eye, and so therefore this is 2 slices from the same eye. So we're going to select those, drag them over here. They're both going to pop up. And the way this algorithm works is I'm simply going to hit run. Well, you want to ensure that there are no other images open, because it'll mess up the algorithm. So you have these 2 open, and then you're going to hit run. And then you'll see it binarized and standardized them. And you'll see that this algorithm automatically spits them all out right here. So, for the sake of time, I'm just going to quickly run through the rest. will see that as I keep doing them, it will keep spitting them out down below. Okay, so just to show you guys what exactly all this is, so this is the binarized image. This we won't be using, but it's needed for the algorithm. It binarizes it, and then that's how it uses to find the projection artifacts, something like that. So what we're going to do is we're going to cut these out from here, and we're going to paste them into the subtraction binarized. Just for the sake of organization, we're not going to be really working with those. Then here, this is the standardized. Same thing, we're just going to put them in their right bins, so to speak. And so the ones we're really going to be working with are the ones, these ones, projection artifact removed. And you'll notice we now have double. We have a standardized version and a non-standardized. And when we're saying standardized, we're saying that the image is standardized within itself, within its own mean black and white ratio. The implications of this I'm not entirely sure of, and I'm not sure if Marib is entirely sure of, but it was just done as sort of a cautionary measure in case it does turn out to be significant. So we're going to put them here. And so to review, we have cropped all of our images, and now we've removed the projection artifacts. And to be honest, the images don't look that different than from before, but nonetheless, it's a part of the process of removing the projection artifacts. And so then, the next thing we have to do is we essentially have to align all of our images and crop them to ensure that they are all looking at the same part of the eye. So you essentially want to make sure that the center is the same center among all the eyes, or among all the images. So in order to do this, we're going to go to File, we're going to hit New, and then we're going to go to Track M2 blank. We're going to select this. You can select a storage folder. I just select Completed and Aligned because that's where I'm going to put all these images. Select, and then so you'll see all of this big black box opens. And so what you want to do is you want to do one eye at a time. So we're going to do all of the right eye right now. And we're going to drag and drop. And then what we're going to do is we're going to right click over here. We're going to go to Align, and we're going to go montage all images in this layer. And at this point we just hit OK, OK, OK all the way through, and it will just think, and you can usually get a little status bar that'll show up soon up here. So it's going. Usually the more images you're trying to align, the longer this will take. This should take under a minute, but if you have about 20 images, it can take about 5 minutes to really align, at least in my experience. And so the way this is working, it's looking for major landmarks among all the pictures, and it's going to align them based off of that. So you'll see it wiggled a little bit. And so now the next step is you're going to click this eye over here, and you're going to deselect every single one except for one. Next thing we're going to do is we're going to get this rectangle tool up here, and then you're going to form a rectangle to encompass as much of the image as possible. And so I like to make sure that, you know, each corner is touching an edge, and then there are these little white boxes that I can use to adjust. So now that I've done that, I'm going to click on the next one, make sure nothing's peeking out, which it isn't, and then now this one. And so you'll see it's peeking out down here very slightly. It might be tough to see on the screen for you, but so I'm going to pinch it up, and I'm going to pinch it in, and then we're going to keep going and repeat this process. Okay, that's fine. Fine. That's fine. So we don't have that many images, so this doesn't take that long, but usually this is the longest and most time-consuming step. This is also the step in which variability is usually introduced. So now what you do from here is you select this, you're going to right-click, and you're going to hit Export, Make Flat Image. And then you just hit OK, and then this pops up. So I usually save this as a TIFF, and I pretty much copy whatever's in here, and then I just add aligned. So you can see I've just simply added aligned, and we're going to hit save, and then we can get rid of that. It's highly important in this step that you do not click in the black box at all, or else this rectangle will disappear and you'll have to do it all over again. So we're going to repeat, and I'm sorry, but you're going to have to watch me just repeat this so we can get to the next step. Okay, so that's all the right eye, and frankly, for the sake of time, we're going to just leave it at that. Exit out of this, exit out of this. Yes, I do want to close the project. Unsafe changes. No, actually, I didn't want to do that. Okay, so we're just Xing out of this. This we can't X out of. So now you have aligned the entire right eye. Now comes time for the actual flow void measurement. So what you want to do is you want to have this Excel book that has our thresholds. You want to have that handy. So I'm going to put this right here. And then there are thresholds. Let's see, let me hide all of this. That's just so I can relay the dates with the thresholds more easily. Okay. So now what we're going to do is we're going to get all of our images, and now it's super important that you get the completed and aligned images. When I first started doing this, I always made the mistake of accidentally getting the ones that have just had the projection artifact removed. So definitely make sure aligned is there. We're going to select all of these bad boys, put them up in here. They all pop up. And then we're going to run our final macro. So macro, edit, and now we're doing threshold measurement. So that pops up over here. Now all you simply have to do is hit run, and then you'll see enter threshold 1 for 13117 OD CC AC standard 1. And so for both the standardized and unstandardized, it's going to be the same. So anyways, 13117 CC1, choriocapillaris 1 is going to go with avascular 1. So I'm going to do threshold 1, 10.642. Okay, you'll see it's already highlighted based on, you know, sort of this narrow threshold of blackness. That's what it's determined as a flow void. And now we're going to do threshold 2, which is going to be 20.06, and you'll see it expanded a tiny bit. So now we're on 13117 ODCC, same choriocapillaris 1, not standardized. It's the same two values. Okay, now we're on to 131 choriocapillaris 2. So to remind you, we're at avascular 2. Because this is the second picture of the right eye, and so we want to get to the same parallel second picture of the avascular zone. So I'm just going to continue filling this out as prompted. Okay, so now sometimes you got to be careful because it will jump around the algorithm to different images. It won't be in the order necessarily that it is here. So you'll see it jump down to 10.416 OD, which is down here. Okay, so that's all the right eye. And so this is all, now these are all highlighted, right? And so you'll actually see that this, we're going to X out just so I can prove a point here, is in fact, it actually gets saved right in this completed and aligned folder where we got the images for to run this algorithm. So I usually just cut this out and I throw it in here. And so you'll see that, you know, we'll just select these three. That's been saved with the highlighted results of measurement. Can be thrown into a paper if you're using this algorithm for that. And more importantly, it's actually been saving in the results file right here. So you'll see here, here's all our values. And so it'll give this area. And this area is the flow void area. And you'll see the first value is always based on the first threshold, and the second value is based on the second threshold. So usually the second threshold, because it's 2 standard deviations, is going to have sort of a much wider swath that it considers as black. So it's usually a bit more generous on what it considers a flow void. As for which one is more clinically relevant, that I guess still remains to be determined. Much of the other values here aren't of any current clinical significance right now, neither the mean or standard deviation. But definitely this is how we get our flow void areas, and essentially this is how the algorithm is run. So hopefully that made sense, and yeah, so thank you very much for watching, and that's it.